invoke the study. The study group has been invoke a study session. Oh, this is my jam. Okay, variables and arithmetic expression, data types, and the percentage indicator. I know what I want to cover with this video, but I guess getting started. I'm having a little not trouble, but it's just like I'm not having trouble starting necessarily. I'm not necessarily having trouble starting. I don't think I want to start right now. I don't want to start. Every C program must begin with a main function. In order to start this temperature converter, there's a few things we need to know. Okay, we need to know before we even start writing it. This is like pre-knowledge, You just if you're gonna create a program, you got to know what you're creating, right? You're gonna have a hard time if you just sit down in front of a computer and open up the C whatever you're using, code blocks or Visual Studio Code to start writing a C program, but you don't know what you're writing. If you don't know what you're gonna create, you're gonna have a hard time creating it because there's nothing to create. You just got like, what do I do? Well, if you have you gotta have a reason to be doing this, right? For this reason right here, we're gonna do a temperature converter from Fahrenheit to Celsius or centigrade. We know what we want the converter to look like. We want to have like a chart or like a two-column, one with Celsius, the other one with Fahrenheit. It's gonna have the Fahrenheit degree and its equivalent in Celsius on the other side. Okay. We know we want it to start at 0 degrees, right? 0 degrees. How high are we gonna do the conversion to? Well, the book it goes up to 300, so we're gonna do it to 300. Okay. From 0 to 300, we know our minimum temperature is gonna be 0. We know the max is going to be 300, okay? 0 to 300. Are we going to go one degree at a time? No, we're going to do increments of 20. We're going to do increments of 20. You can do increments of whatever. You can do one by one by one. There's going to be a long freaking chart if you're going all the way to 300. So we're not going to do that. We're going to do increments of 20, okay? So there's three things that we know we have to create for variables. There's a lower variable, the lower limit, the upper limit, and the increments of temperature for this chart that we're going to create. We also know that we're going to have numbers inside our, as far as the Fahrenheit and Celsius. Those two are going to be, there's going to be this, that's got to, there's, what's the temperature for Fahrenheit? Well, it's going to be a number. We don't know what it's going to be yet, but we know it's going to be a number, so that's got to be a variable for, we have to create a variable for Fahrenheit. We have to create a variable for Celsius. We have to create a variable for the lower limit, upper limit, and the increments. Okay. How do you create a variable? Variables are created by declaring what type of variable you're going to use. In this case, we're going to use an integer to start off with. We know it's going to be an integer. When you're creating variables, you can create multiple variables at once as well. To initiate or to start to create a variable, you're going to declare a type of oh, actually, I did this wrong. Proper etiquette. One tab or 4 spaces in within the function. So the function's here. We're opening the statements. We're opening brackets so we can write statements within this function. And to make it clear for other people to understand or read, even for you, make an indent so you know that inside this main function, we're creating an integer. The first one is going to be called Fahrenheit or Fa, and then comma. The second one is going to be Celsius. Okay, end statement. Now, next line, we're going to create 3 more integers, or 3 more variables that are integers. One for the lower limit, we'll call it low. Next one's going to be the upper, up, and then STP for step or increments. Okay. Okay. Oh, forgot. Don't fucking forget. Semicolon, end statement. Okay. That's what we're going to start off with. We're starting off with 5 variables. Okay. They have not been assigned to anything. They're just empty variables. These variables must be declared before you include them within your code. Now we got to start assigning shit. All right. So we know what the lower is. We know what the upper is. We know what the increments are. And we know what we're going to start Fahrenheit. What we don't know is the conversion yet, right? We don't. So next, we're going to set the lower limit, low. What is low? What's our lower limit? We just mentioned it earlier. Integer, by the way, data types. Integer is a data type. Low is equal to 0, end statement. Upper, or up, is equal to 300, end statement. And step, or STP, equal to 20. Okay? Where am I getting these numbers from? Our lower limit, we're starting our temperature at 0 degrees, and then we're going to keep going, converting the temperatures up to 300. We only want to go up to 300. And from 0 to 30, we're going to get from 0 to 300 in increments of 20, or in steps of 20 degrees. Okay? We have 2 more integers that we need to, or variables that we need to assign, or 2 more variables that need assignment. Fahrenheit. What are we going to do with Fahrenheit? What should we assign Fahrenheit to? We can assign it to anything, all right? We can assign these numbers, these variables, to anything we want. These are completely flexible. We can do whatever we want. But but we have a goal. We have an idea of what we want to do. Okay. We're gonna start from 0, go to 300, right? 0 to 300. So wouldn't it make sense to have Fahrenheit, which is what we're converting? We know Fahrenheit 0 degrees. We know Fahrenheit. We're familiar with Fahrenheit 0 to 300. We know those. So if we're gonna start a converting program, let's start Fahrenheit at 0 degrees. Okay, because that's the first step. That's the beginning. That's the lower limit. That's our start. Okay, so Fahrenheit. Let's set Fahrenheit to 0. Fahrenheit, and how do we do that? Fahrenheit is equal to low. All we're doing is saying Fahrenheit, assign it to whatever low is, and low is always going to be 0 degrees. It's just our those are our parameters. Our numbers aren't. Those numbers aren't going to change. And we could change them if we want, but it's not going to change in this instance. So we want Fahrenheit to start at 0. Let's set Fahrenheit to low, which is 0. What we're going to do with this temperature converter is going to do, it's gonna run a formula. Minus 32 degrees. You might see it in different ways. It can be written many different ways, and that's part of what section 1.2 describes or talks about, is that there's multiple ways of writing a program, a formula, arithmetic expressions. While Fahrenheit is less than or equal to, or upper, sorry, not 300. 300, we are Sparta. While Fahrenheit is less than or equal to upper, that's the argument. Arguments are found within after the function. The arguments are within the parentheses. There's no arguments here within the main. It's just empty set here. The while function, while Fahrenheit is less than or equal to upper, we want it to do something. What is it that we want it to do? Do that. Okay? Keep in mind, we have one open braces, two open braces. We're gonna need two closing braces. Always remember that. For every open brace, same thing with the parentheses, you're gonna need a closing one. So we have two. That's a second open. Just keep that in mind. Just remember that's important. Well, Fahrenheit is less than or equal to 2. Celsius is equal to 5 divided by 9. And you're gonna plug in this formula. Fahrenheit minus 32. In a statement. Okay. What we also want to do is we're going to want to see it because it's going to be a chart. It's a chart. It's a chart with two columns. It's something we're going to want to see. It's a conversion chart that we're going to look at. So the function for an output. Let me see the conversion via printf. Space it out. Do better spacing. Okay. So the indicator, this percentage indicator, it's basically a placeholder for the variable. Okay. A placeholder for the variable. Something that printf can look at to point to, right? It's something that points to it connects the variables to printf forward and back. Okay, printf percentage d. What d is says as we mentioned before. I think I've talked about this in the last video. Percentage d is just saying this is going to be an integer. Percentage d is integer. Percentage c would be a character if it was letters, but since we're dealing with numbers, whole numbers specifically, it's going to be an integer. Percentage d. So by default, this is what the numbers are going to be spit out like. Justified left. They're going to be lined up on the left. First number is going to be 0. Is going to be on the left column. Same thing with this side, the Celsius. The negative is going to take up one spot. The 4, 1, 2, 3 are going to be in line. And then it's just going to look funky. That's not what numbers are supposed to look like, right? It's not what you're used to seeing. It's not what everyone's used to seeing, right? It should be justified right. So where it's 0 here, and then 100, right? That's justified right. Well, in order to accomplish that within C, we got to use this percentage indicator thing. This percentage indicator. That's where you're gonna make the adjustments. That you can adjust the width of the number and how many decimal points you want that number to show up at before. But d is an integer. An integer is not a decimal point number. It's not a fractional number. Floating point numbers are decimals. This is properly has to be 6.1f because you're declaring a floating point. You're declaring decimals. When you're initially creating your variables, you have to declare instead of integer. Remember when we create integer Fahrenheit, Celsius, integer lower, upper, mid? Well, instead of integer Fahrenheit, Celsius, we have to create float Fahrenheit, float Celsius. Integer, long integer, double float point. What the differences are the amount of the size. Characters are a single byte when you're talking about storage. That's what these are. That's what the difference is between short and long. It reserves a certain amount of space within the computer, within the memory in the computer, for whatever type of data type you're declaring, because it's data. It's hard drive space. It's information that we're saying we're gonna store, we're gonna use, we're gonna create, or we're gonna manipulate. An integer, a fractional number, a character, string character, 1 byte. Okay, 1 character is 1 byte, and that's what the difference is. Each one is gonna has a reserved amount of space. A short integer versus a long integer. The long integer is gonna have more space available to store information within that variable. Okay.